When you create a mission, the logic may become quite complicated and extensive. You'll find quickly that when you're creating a scripting solution in your mission, that you're actually designing a flow, a process of events and things that happen within your mission. Objects are created, objects are deleted, goals need to be achieved, players join, players leave, So all these different events are orchestrated. The Moose framework helps you to orchestrate all these events, but that doesn't mean that you as a mission designer understand, clearly what is going on in your mission, and many questions will arise. Fortunately, the Moose framework provides you with a small pragmatic tool that allows you to trace the flow of the process that's happening in your mission. And I'm going to explain you the basics of what you need to do to understand what your mission is doing at certain points in the logic, and when you have a problem or a question, what you need to do to try and find what is wrong or what is wrong within your code so that you can correct it independently from others. So let me quickly get into what the tools are within the Moose framework that allows you to trace your logic in your mission. Okay, for this I'm going to the documentation site on the Moose framework, and then here you find the base class. So the base class is the base of the Moose framework. Any other class derives from base. So scheduler, right? When you look at the scheduler object, it derives from base, right? So what is base? Base is basically a collection of methods that are so core within the Moose framework that they have to be, the basis of the basis. And one of the core methods is tracing events. So what are tracing events? Let me get into, the base class documentation, which is a bit below. So as I said, all classes of the Moose framework are derived from the base class. There's a hierarchy system, there's some debugging purposes, methods created, and here you find different methods that allow you to put tracing information in your mission logic, and it will be written in a file called the dcs.log file. So when I'm writing, for example, self.e hello, it will put the word hello within the dcs.log file. And I will show you how this logging looks like. Right? I'm not going into details on how this all is done. But what is important for you to remember, you got 3 major categories of tracing methods. The first one is the E, the second is the F, and the third is the T. The E is always traced. So when you use the E method, regardless of any tracing setting, switch or anything, it is always written within the logging. You can use this for error logging, but also for when you put your mission into production, you want to ensure that information is always traced. So when there's a problem, you have some way of understanding what was going on. The F and T can be switched off. So when you are designing your mission, you can switch them on. Tracing will be done, but when you get into production, you can switch these tracings off, which will save CPU time, IO time, and you don't need to delete them from your mission file. However, because the T and the F take some CPU, it is recommended, that's what I'm going to do, is recommended that when you put the stuff into production, that you comment the lines which have an F method and a T method applied. And this is something that you can do within the LDT with an automatic replacement. But for the moment we leave them into your mission. So an F is basically used when you open a new function, when you get into a new function and you trace the input parameters of the function. The T is used within a function, but it then explains what kind of variables you have within that function as the logic within that function is progressing. There are tracing levels, because I also noticed when designing the Moose framework, and these methods are extensively used within the Moose framework, that after a while the tracing becomes really exhaustive and big, and it becomes really difficult to understand what's going on because of all the information that's been logged. So I created levels, a level 2 and a level 3. So an F2, again, this is a switch that can be activated. So a level 2 traces on level 2, level 3, right? When you have level 1 activated, those lines will not be traced at all, will not be shown in the log. So how do you switch the tracing? Well, you do base double point trace on off, and you give a true, then it's on. You give a false, and then it's off. Alright? You activate all tracing to the trace all method. So when you go to the trace all, you say I want to have everything traced regardless of, on, off, whatever, level. So you can trace certain classes. You can say, no, I would like only the output of this class. So when you do that, you give as a parameter the string of the class that you only want to trace. You can even trace a method. So within a class, there's a certain method, and you only want to trace the logic of that method. You can do that with this API. And then the most important, I think, is the trace level. You can say I would like to see the output on level 1, level 2, level 3. You can check if tracing is on with the method isTrace, which returns a boolean, true or false. Okay, so these easy methods allow you to quickly debug what's going on in your mission. Now let me get to a demonstration how these things are used and how this looks within your logging. Right, so I'm in the mission editor, and I have this demonstration mission called Demo Trace Mission. There's a helicopter here, late activated, with the group name helicopter. This helicopter will not be shown normally when you start your mission without any scripting. But I've done the following. I'm loading Moose here. So I'm loading the moose.lua. In this case, I'm loading it dynamically, and I will show you in the log how this looks like when you load it dynamically. And I'm creating a new script file now at mission start, load mission, new, do script file, missions, my missions, demo trace mission. And this is the file that I'm editing here, which is located here. Right? I got one sentence in here. Local helicopter spawn equals spawn double point u helicopter. The spawn object will look for a group late activated called helicopter, and we'll create that as a template for any future spawning of helicopters. So in the mission here, I got load mission. This Lua file is loaded, and I can just, run, and it will do something. Let's look what it will do. So when I run the mission, starting, nothing happens. But fortunately, I'm having a logging here, a logging tool. So when you execute a mission, there's a file created, dcs.log, and that file can be located in your saved games directory. So in my case, users, Sven, saved games, I go to DCS, and I go to logs, the logs directory. And in here you have a file called dcs.log. When you open it, you will get, a notepad or any other default editor that you have, and it will show the log, right? But there's a much better alternative on the web that you can do. You download the logging trailer tool, and the best logging trailer, I've tried many, but the best logging trailer that I would recommend is the glog, Glogg tool. You can find it here. So how you find glog is you go to Google. Let me go quickly from the base. So you do this, Google, you type glog, first hyperlink, the Fast Smart Log Explorer. This is the website. Okay, so download this one, install it, and run it. And then within the glog, when you run it, by the way, it's useful to pin it on your taskbar so you can quickly access it. And then when you run it, you open the log file. You need to open the dcs.log file, which can be found in the saved games, dcs logs, dcs.log here. Then you load it, and then you get the tracing of your dcs.world execution, which you may already know. But the thing is, this is trailed. So when you run your mission, you see, when something is written in your log file, you see it immediately appearing. And this becomes really handy. And what I'm going to do in this mission that we had, I'm going to access and, create a trace, a log. So what I'm doing is I'm adding another trigger. I'm moving it right after loading moves, but before loading my mission. Trace. What I'm going to do now is I'm switching on certain tracing variables using the methods as outlined within the documentation. So I'm doing trace on, off, true. I'm activating trace. I'm doing trace all, true. I'm going to trace everything. I'm doing trace level 2. So when doing this, now I'm going to trace a lot of materials when my mission is being executed. Let me go into the the demo trace mission right here. So what I did is I spawn a new helicopter. No, I create a new helicopter spawn object. From that object, I'm spawning the helicopter object to see. No, I'm tracing what is in the helicopter spawn object. And then I'm saying trace hello world from base. And then I'm spawning a helicopter using the helicopter spawn object. So how will this look like within the log when I'm executing it? So I started the process. There's a helicopter being spawned. It starts to fly. Very interesting. But now you see the tracing being quite extensive. So you see moves being loaded, you see the database being scanned, and then it says trace all, tracing all methods in moves, trace level 2, and then it says, well, within the moves framework there's a lot of debugging already done, so you can see the line number and the object where the tracing has been done. I should also maybe mention the file. Maybe I'm thinking on showing the file name where the tracing is being done as well. So you can quickly see file and then the line number, and then you see all the stuff coming out of it, right? Now of course this is too much information, so imagine for one small spawn I'm seeing all of this information, and you don't want that. So what you do is then do the following. Maybe I'm spawning too much, maybe I'm tracing too much, so maybe I just would like to spawn level 1, trace all off because it's too much, and do this, trace class, and say base between as a string. Just write base and rerun. So now I get a bit less information when I executed this mission. So what I'm doing is the spawn object won't be traced because I'm only tracing class base. So base will be traced. So go into base, go into the log again, and then you see hello world here. The spawn object, the spawn object is traced because it's an E, so it always writes anything with an E. But the T is only written when it's traced. So we're only tracing the base class, so this is written. And then you get a lot of other E, E type of messages here. An important one is this one, on event, and then event birth. When you see this, it means something was born within your mission. And then it starts to evaluate, you know, using the event driven mechanism. By the way, that is explained here. Let me go quickly to it so you can follow this, what I'm talking about. You should watch the, oh my god, my son, what did he do? Let me go back here. Right, so you should look at event handling here and watch these videos, especially this one. Yeah, because this one is explaining very quickly in much detail what event handling does and moves and how that is, you know, how that is influencing your mission. So the tracing of the events are written here, and it evaluates the object database. It evaluates, do I have event processing for spawn? And when it does, it will say call event function for class, and then an event function with a priority number behind. I don't want you to really debug the moves code. That's not my intention of this session, but I would like you to understand that you can add your own variables here. You know, so let me go quickly to what these variables are, and you know what let's say what kind of information you can put in those methods here. Yeah. So we got this spawn thing. Now I'm going to create an array. So I do array equals 1, 2, 3, right? So I can do now base E, no, base T, let's call it, just because then I'm tracing and I can switch it off later. So I can do trace me the array just like this. I'm gonna do just like this, array. Right, it's a global variable array, trace it. Of course I need to rerun my mission, and I need to re-import my mission file. That's a very annoying action that you always need to do. Right, the mission file is there, the helicopter is run. Let's have a look at the logging. What does it say? Here we are. The logging says here at line number 10, which is here, and by the way, the line numbers can be configured in this way. You go to Window Preferences in LDT, you go here, Editors, I think, where was it? Text Editors, yes. So in General, Editors, Text Editors, and then here you have Show Line Numbers. Activate the switch, and then you can see the number here. So, oh my God, what am I doing? Go back to the logging. Now you see 1, 2, 3. This is the first element in the array, the second and the third. Okay? So let me get a bit more advanced now. Now I'm going to say, well, how do I know it's an array? So I can do this, array is array. What does that tell me is, because the input is actually an array, I can say the first element of this array is called array. It's a bit confusing maybe, but I need to put it like this, between brackets. Okay, fine. So like this. I'll re-import the file again. Save. Prepare mission. So the mission is run. And right now what you see is here. It says array equals 1. Equals 1, 2 equals 2, 3 equals 3. Very interesting. So you can put any variable into this kind of tracing information. If you really want to be sure, you put the information between brackets and it will show it as an array of itself. Yeah? So any information can be put in there. So I really hope that this kind of, you know, debugging functions will help you to trace your missions and really play with the variables and get accustomed with how tracing works. Any question can be raised to me, either, you know, on Slack or on the forums on Eagle Dynamics. Thank you very much. I don't want to make this video too long, so I'm gonna close it here. Bye bye.